In example number 5, we're finding the solution to a dependent system of equations. So we're going to find the solution to the given system of 3 equations and 3 variables. So if you look at the first 2 equations, we can possibly eliminate the x, or we can eliminate the y, or we can eliminate the z. So if we look at the first variable x, we can multiply the first equation by -2. So -2 times 2x is -4x. -2 times y is -2y. -2 times -3z is +6z. And -2 times 0 is 0. And then we're going to keep equation 2 the same. Now when we add all 3 of those variables together, all 3 of them are going to give us 0 on the left side. On the right side, we're going to get 0 as well. So if 0 is equal to 0, that is a true statement. So we do not need to proceed any further. The result we get is an identity which 0 is equal to 0. Which tells us that this system has an infinite number of solutions. There are other ways to begin to solve this system, such as multiplying equation 3 by -2 and adding it to equation 1. We then perform the same steps as above, and then we'll find the same result, that 0 is equal to 0. Now, when a system is dependent, when we get a true statement, we can find general expressions for the solutions by adding equations 1 and 3. So when we add those equations together, we get 3x, we eliminate the y, and we get -2z, which is equal to 0. Now we've created this fourth equation. In this fourth equation, we then solve the resulting equation for z. So we subtract 3x to both sides and divide by -2, so we get z, which is equal to 3 over 2x. So over to your right, this is solving in terms of x. So we can write what that z ordered triple is. So the z is going to be 3 over 2x. Now we then back substitute the expression for z into one of the equations and solve for y. So it doesn't matter which one we choose. So in this scenario, we're going to choose equation 2. Equation 2 is 4x plus 2y minus 6 times what we got for z, which is 3 over 2x, and that's equal to 0. Well, if we take -6, we're going to keep the sign. 6 times 3 is 18, divided by 2 is 9x. So now we have 4x plus 2y minus 9x is equal to 0, and again, what we want to do is solve for y. So we add 4x and minus 9x to get -5x. We add 5x to both sides, so we have 2y, which is equal to 5x, and then divide by 2. So now we have the y term of the ordered triple. Y is equal to 5 over 2x. So we write 5 over 2x. Now, because we're solving z and y in terms of x, then we're going to leave x as x in that x coordinate. If we come back to 4, we could have solved for x and wrote everything in terms of z. So it doesn't necessarily matter which way you go about it, but when you get a dependent system, this is what your solution is going to look like. Because no matter what you choose for x, it's going to give you a solution to the system. So the general solution is x, 5 over 2x, 3 over 2x. And in this solution, x can be any real number. And the values of y and z are dependent on the value selected for x. So as shown in figure 5, 2 of the planes are the same and they intersect the third plane on a line. So the solution set is infinite, as all points along the intersection line will satisfy all 3 equations.